Hey guys, today I want to talk about quadratic functions. Quadratic functions are any polynomial where the highest exponent is a 2. So you have x squared terms. When you talk about quadratic functions, you have this general form given here, f of x equals ax squared plus bx plus c. You have your x squared term, your x term, and your constant term, the one without a variable. And then we're going to worry about graphing them first of all. And when you graph a quadratic function, it creates a curve that looks something like this, a U. And it is called a parabola. Now it might be skinnier or wider or in a different location, but it's always this U shape when you graph an x squared function. So how are we going to graph that? How do we get that U shape? So let's look at this with an example. F of x equals x squared plus 6x plus 8. Now you need to know in algebra, if you ever graph anything, you can always try to use an xy table. So you choose a bunch of random x values, you find the y value by plugging into the function, and graph it. This is not how we're going to do this one. We're going to have a little more process to it, but let's just see what happens if we do this. So I choose whatever x values I want. -2, -1, 1, 2, and I plug each of them into the function. So f of -2, f of -1, f of 0, f of 1, f of 2, sort of a lot of work, but we're going to do all of these, and we plug it right into the function. So I have -2 squared plus 6 times -2 plus 8, so that is 4 minus 12 plus 8, which is -8 plus 8. If you miss a step in the arithmetic here, just pause the video and think about it for yourself. So I have -1 squared plus 6 times -1 plus 8, which is 1 minus 6 plus 8, which is 3. When I plug in 0, I have 0 squared plus 6 times 0 plus 8, which is equal to 8. Plug in 1, I have 1 squared plus 6 times 1 plus 8, which is 1 plus 6 plus 8, which is 15. And when I do 2, I end up with 2 squared is 4 plus 12 plus 8, which is 24. And when I plot those, because once you create the table, you can then plot it on your coordinate plane, I end up with something like this. I go to x equals -2, and I put 0. And then I go to -1, and it's a y value of 3. And then I go to 0, 8, and I'm already way up here. When I go to 1, 15, I'm way up there. Where's my U shape? I only seem to have one side of it. I don't have the other side. And see, that's what can happen if I just randomly choose my x and my y's. I don't know which ones are good, so that I would choose values and give me points that would allow me to graph this parabola. So let me tell you a good process to choose your points. And we're going to choose 5 points that will then let me graph a good parabola. Now when you graph a parabola, it has this lowest point, or sometimes it's upside down and it has this highest point. Those points are called the vertex. That's the first thing we're going to find. Where is the vertex? And there is a nice little formula for that, and it is x equals -b over 2a, and it gives you the x value of the vertex. And so that -b and 2a is talking about the numbers next to your variables. And so I plug that in, and I get x equals -b over 2 times a. That's -6 over 2, which is -3. That gave me the x value of a vertex, but you know that every point has an x and a y. And so I find the y by plugging that x value into the function. So I find f of -3. -3 squared plus 6 times -3 plus 8. 9 minus 18 plus 8. -9 plus 8, and it is -1. So my vertex is at the point -3, -1. So I kind of already know something about this parabola now. If I go to -3, -1, That right there is my vertex. So I kind of know that my graph is doing something like this, but I got to find more detail. So here's the next thing I'm going to tell you. A parabola has an idea of symmetry, where on the right and the left side, it increases by the same amount. So what I'm trying to say is, if I find a value right here, on the left side, I have a corresponding one here. If I find another value right here, I have a corresponding one on the other side. There is a symmetry. And so once I find my vertex, I create my XY table taking advantage of that symmetry. I'm going to find 5 points, and I'm going to put my vertex in the middle, -3, -1. And then to choose the other x values, I'm going to add 1 and add 2 from my vertex. So I go -3 to -2, and then -3 to -1. And I go the other way, and I go -4 and -5. So I put my vertex smack dab in the middle. I then am going to evaluate the function at each of those terms. So I plug in -1. We already have done this, but -1 squared plus 6 times -1 plus 8 is 1 minus 6 plus 8, which is 3. And I plug in -2. We've already done this one too, but -2 squared plus 6 times -2 plus 8. And that is 4 minus 12 plus 8, so that is 0. Then I'm going to go to the other side and do f of -4, and that is -4 squared plus 6 times -4 plus 8. That also equals 0. Pause the video, do it for yourself. F of -5, plug in -5, and guess what? If I work that out, I'm going to get 3. I now find 5 points, and these ones are very good because they give me points on both sides of the vertex. So I'm going to plot -2, 0, -4, 0. You see that symmetry at work? And then I'm going to do -1, 3, and then -5, 3. There is this symmetry at play, and notice it in my table. Here's the vertex, and on either side, the y values are the same. 3 and 3, 0 and 0. That's what happens if you set up your XY table in this way, where you put the vertex in the middle, and then you add 1 to each x value, and then you add 2. So I create symmetry with my x values, and the y values have the same type of symmetry. And that allows me to choose those excellent x values so that when I plug it into the function to find my y's, it gives me points on either side of the vertex and allows me to correctly and accurately graph my parabola here. And so that's your process. You start by finding the x value of the vertex using our equation x equals -b over 2a. You then plug that into the equation to find the y value of the vertex. So I now have my vertex. I go over and I create my table. I create it in a very specific way by putting the vertex in the middle and increasing by 1 and then increasing by 2 and then going to the other side and subtracting 1, subtracting 2. I then plug all those values in, but I recognize the symmetry of the y values as well. And then I plot those on my coordinate, on my graph, and I connect the dots. And there you have the graph of a quadratic function.